Good morning, my YouTube viewers. In this video, we're going to be talking about experimental design, and we're going to go over a completely randomized design, CRD, where experimental units are randomly assigned to all treatments, making this design simple and effective when variability among units is minimal. And so basically, we've got a practice question to go over completely randomized design. The practice question is, a medical researcher wants to test the effectiveness of 3 different groups, A, B, and C, on lowering blood pressure. They randomly assign 60 patients to 3 equal groups, 1 for each drug. How should they conduct the experiment, and what statistical methods should they use to analyze the results? So that's the question. So this one is completely randomized design because that's what we're studying. And we're going to write a program in Python to carry this out. And so before we write the program in Python, what we have to do is we have to input some libraries, and libraries are necessary to help execute Python programs. So the first library that we're going to import is NumPy SNP, which is a numeric library and also creates NumPy arrays. The second library that we're going to import is Pandas SPD, which is a data processing library, and it also creates data frames and series. The third library that we're going to import is matplotlib.pyplot_splt, which is a visualization library. And then from scipy.stats, we're going to import f1way. And scipy is Python scientific library. Stats is a statistical module within scipy. And f1way is the test that we're going to be carrying out. So in order to run this program, what we have to do is we have to set the seed. And the reason why we set the seed is so that every time we run the program, all of the variables will be initialized the same. So you set the seed by typing np.random.seed, and you can type any number you want within the brackets. So there's going to be 20 patients per group. And now we're going to simulate the drug data. So drug A reductions equals np.random.normal brackets 10, 2, patients per group. So that's a normal distribution and has a mean of 10, a standard deviation of 2, and 20 patients per group. And drug B reductions equals np.random.normal brackets 15, 3, patients per group. So that's a mean of 15, a standard deviation of 3, and 20 patients per group. And drug C equals np.random.normal brackets 12, 2.5, patients per group. So drug C has a mean of 12, a standard deviation of 2.5, and 20 patients per group. And the 20 patients per group is your sample size. So what we're going to do now is we're going to use Pandas to create a data frame of the data. So data equals pd.dataframe brackets, curly brackets, drug A times patients per group plus B times patients per group plus C times patients per group. So that means you've got 20 A's, 20 B's, and 20 C's. And reduction equals np.concatenate drug A, drug B, and drug C. So now what we're going to do is we're going to do a summary statistics on these 3 drugs. Summary equals data.group by brackets drug square brackets reduction dot aggregate mean standard dot reset index. And so now we're going to perform an ANOVA. That's an analysis of variance test. So F stat, comma, P value equals F1 way, brackets, drug A reductions, comma, drug B reductions, comma, drug C reductions. So now we're going to print our data. So we're going to print summary statistics and then the summary, and then we're going to print ANOVA results and the F statistic and the P value. So what we'll do is we'll go down to the bottom of the cell. So your summary statistics are drug A has a mean of 9.6 and a standard deviation of 1.9. Drug B has a mean of 14.2 and a standard deviation of 2.9. And drug C has a mean of 11.9 and 2.5. Your ANOVA results is your F statistic is 18.970 and your p-value is 0. And so basically what it is if the p-value is less than 0.05, this means the null hypothesis has to be rejected. The null hypothesis is there's no difference between the readings, and the alternate hypothesis is there is a difference between the readings. And since the p-value is less than 0.05, you have the result. There is a significant difference in the effectiveness of the drugs, so that's going to be your alternate hypothesis. So now going back to the p-value, and this is the code for what I just said. If p-value is less than 0.05, print result. There is a significant difference in the effectiveness of the drugs. So now we're going to visualize the data in the form of a box plot. plt.figure, brackets, fig size equals 6,4, data equals box plot, brackets, column equals reduction, comma, by equals drug, comma, grid equals false, comma, patch artist equals true, comma, box props equals dict, bracket space color equals light blue, comma, color equals blue, comma, median props equals dict, brackets, color equals red. The title is Effectiveness of Drugs on Blood Pressure Reduction. There is no subtitle. The X label is drug. The Y label is blood pressure reduction in mmHg. The grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. So you've got your plt.type layout and plt.show. So we're going to show the graph that we have just made. So you can see here in the code, it says the median is in red. So the median, the red mark on this box plot is your median. And remember, there's a difference between the mean and the median. The mean is the average, and the median is the center. And so you can see drug A, B, and C. You can see that there is a significant difference between the values of A, B, and C, which means that the null hypothesis would be rejected and the alternate hypothesis would be accepted. And you see drug B has the greatest variance between the three drugs. So that concludes this video. The next video is going to be on another experimental design. So I hope that you decide to watch it.